So let's take and start another example from a NCERT book, that is example number 6. Okay. So let's have the example. According to the example, it is given ABCD is a parallelogram. So at first we have to draw a parallelogram ABCD, right? So this figure is a parallelogram A, B, C and D, right? In which P and Q are midpoints of sides AB and CD. Okay, since there are two sides AB and CD, and these two are opposite pair of sides, right? So P is the midpoint of the side AB. It is given. Let's say this is AB. Then this is the midpoint of AB. Suppose this name of the point is P. Similarly, Q is the midpoint of another pair of the side, that is CD, right? Let's say this is the midpoint of CD and the name of the point is Q. Okay. If AQ intersect DP at S, AQ, so we have to join the point A and Q. Okay. So let's join them. This is AQ. And it intersect DP, so we have to join again P with D. Okay, as you can see, AQ and DP, right, intersect at a common point. Okay, let's say the point is S. Understood? And BQ, this is BQ, so let's join BQ. Okay, intersect CP. Okay, so let's say this is CP. So BQ intersects CP at another point R. Suppose the name of the point is R. Okay. So this is the complete diagram. We got it from the data that has been given in this question. Okay. It is given ABCD is a parallelogram. P is the midpoint of AB. Q is the midpoint of CD. Right. Then AQ and PD is joined. Then meet each other at common point S. PC and BQ are joined. That meet each other at a common point R. Now from this following figure, we have to prove these three statements, right? We have to prove these three statements. Okay, so what are the statements? First statement, we have to prove APCQ. APCQ. That means this is APCQ, right? APCQ. This is a parallelogram. Okay. Secondly, we have to prove DPBQ. So DPBQ, this quadrilateral, DPBQ, right? This is the parallelogram we have to prove. And lastly, we have to prove PSQR. PSQR is also a parallelogram. So let's start with the proof of the first statement. Okay, so proof of the first statement. Right. Since for the first statement we have to prove APCQ is a parallelogram. APCQ is a parallelogram. Now, since it is given that ABCD is a parallelogram, right? So you can write, since ABCD is a parallelogram. Understood? Now, if it is a parallelogram, then we know the pair of opposite sides are parallel as well as they are equal. Okay? So we can write AB side is equal to DC side and AB side is parallel to DC side. Similarly, we can write this side AD is parallel to BC and also equal. So for our convenience, we can take only one side or one pair of side. Let's say AB and DC. Okay. So we can write then AB is equal to DC. Okay. And AB is parallel to DC. Is it clear? Okay. Then we'll do what? We'll multiply half on this side and on this side. Okay. Multiply half on both the sides. So half into AB. Similarly, here you can multiply half into DC. Understood? Now, half of AB means what? Half of AB means what? So this is AB. Half of AB means this point P, because P, it is already given that P is the midpoint. P is the midpoint of AB. P is the midpoint of AB. Okay? It means if we make half of the total length AB, then we will get either AP or PB. So P is the midpoint. It means half of AB means we can write either AP or we can write PB. Do you understand this? Do you understand this? P is the midpoint of AB. So half of AB means either this half PB or you can say AP. Right? Now, so in this place half of AB, we can substitute AP. Okay? So we can substitute AP. Clear? Next, as you can see in the right hand side is given half of DC. Okay, half of DC. You know it very well. You know it very well, right? You can write it down in the given statement. Okay, you can write it in the given statement. Next, see, Q is the midpoint of DC. Okay, so Q is the midpoint of DC. So I am writing here. Here I am writing here, right? So there is no space, so I am writing here. So Q is the midpoint. Q is the midpoint of DC. That means if we make half of this total length DC, we will get either this half or this half. Simple thing. So if we find the half of the length DC, then we will get either this length or we will get this length. Is it clear? Okay. So now in the place of half of DC, we can substitute CQ. This is CQ, right? So we substitute C. So what we get? Initially we know that this side is equal to this side. Now we will make half of the both sides, then we will get half of AP means AP and half of DC means CQ. Okay? Suppose this is one of the equation. Equation number 1. Okay. Now, here as you can see, already we know since ABCD is a parallelogram, so this side is parallel to this side. Okay, the total side is parallel to total side. Yes or no? Yes. Then can you say this one, this half, okay, is parallel to this half? Obviously yes, because suppose this is parallel to this side. See, then if we take some distance, some length of the total length, if we take some length of the total length, this portion, then definitely this portion is parallel to, if we take this portion of the total length, definitely because the total line is parallel to this line. Okay, if we cut it out, then this half is definitely parallel to this half. Is it clear? So, since AB is parallel to DC, so we can write AB means we can write AP because AP is a part of AB. Similarly, in the place of DC you can substitute CQ. Why? Because CQ is also a part of DC. This is the total length. CQ is a part of DC. You can write it is parallel to CQ. Okay. So what we have got? So we got that AP is parallel to CQ. Let's say this is our equation number D. Is it clear? Okay, so what we have got finally? In the equation 1 we have got for the quadrilateral APCQ. Okay, so you can write for the quadrilateral APCQ, right? For the quadrilateral APCQ. Okay, this quadrilateral. What do we have got? We have got this side is equal to this side. AP is equal to CQ. So you can write one pair of side is what? They are equal. And in the equation number 2, what do we have got? We have got they also AP. This is AP. This is AP. This is AP. Okay. They also parallel. Okay. So one pair of side is equal and parallel. Do you got my point? So in this quadrilateral, we have got this side is parallel to this side and this side is also equal to this side. Now just remind theorem number 8.8. It states that if in a quadrilateral, okay, if in a quadrilateral like APCQ, any pair of side, any one pair of side are equal and parallel, then it is a parallelogram. This is theorem number 8.8. So here we get for the quadrilateral APCQ, one pair of sides are equal and parallel. It means we can write hence APCQ is a parallelogram. Why? Why we have written this? Because we know it from the theorem number 8.8. Okay. If any pair of one pair of sides are equal and parallel, definitely it is a parallelogram. And here we have proved that APCQ is a parallelogram. Then this is done. We have proved the first statement. Let's move to the proof of the second statement. Okay. So we have proved the first statement that APCQ quadrilateral is a parallelogram. We have proved it. Now we are going to prove another statement, that is DPBQ. Which one? DPBQ. This quadrilateral is a parallelogram. We have to prove. Okay. So here also we have to follow the same procedure that we have done in the statement 1. Okay. So how we can prove? So as we know, ABCD is a parallelogram. Since it is a parallelogram, that means the pair of opposite sides are equal and parallel. Right. So we can write that ABCD is a parallelogram. Okay. Parallelogram. So we can write that this side AB is equal to this side DC. So AB is equal to DC. And these two pair of sides are also parallel. So AB is parallel to DC. Now we will do what? We will multiply half to this side and to this side. So half of AB is equal to half of DC. Okay. Half of AB. Since AB is the total length, we know P is the midpoint. P is the midpoint of AB. It means half of AB means this half is equal to this half, since P is the midpoint. So this distance is equal to this distance. Okay. Similarly, if you consider DC side, right? Q is the midpoint. Q is the midpoint of DC. It means if we make half of the total length, then we will get either this length or this length. Okay. Is it clear? So it is given Q is the midpoint of DC and P is the midpoint of AB. So in the place of half of AB, we can put this value or this value. Okay. So for our requirement, we have to take which one? We have to take this value, this half. Okay. So we can write PB. Similarly, half of DC. Half of DC means we can put or we can substitute DQ. Say DQ. Are you clear? So this is the equation number 1. Equation number 1. Is it clear completely? Okay. Next, see, AB is parallel to DC. This side is parallel to this side. Okay. AB is parallel to this. Then this one is a part of AB. If we take PB, suppose this is our AB. We take this portion PB. Then this PB is a part of total length AB. And if we consider DC as a line, right, then DC as a line, then DQ is also a part of DC. Yes or no? Yes. Already it is given AB is parallel to DC, this line is parallel to this line. Then we can write that this part, PB, because PB is a part of AB, is also parallel to what? DQ, because DQ is also a part of DC. Okay. So we can write that PB is parallel to DQ. This is our equation number 2. We can write it equation number 2. Now consider the quadrilateral DPBQ. DPBQ. Okay, so in this quadrilateral, right, in this quadrilateral, PB and DQ are two pair of opposite sides. Yes, and in the equation number 1, we have found that PB is equal to DQ. We have found it. So this distance is equal to this distance. Clear? And in equation 2, we have found that this side PB is parallel to this side. This is parallel to this. Yes or no? Yes. So what we have got? We have got in this quadrilateral DPBQ, one pair of opposite sides are equal and parallel. Now according to the theorem 8.8, we know if in a quadrilateral pair of opposite sides, one pair of opposite sides are equal and parallel, then it is nothing but a parallelogram. So simply we can write for quadrilateral DPBQ, okay, one pair of opposite sides is parallel and equal. Parallel and equal. It means it is, or this quadrilateral is a parallelogram. It means DPBQ is a parallelogram. This is due to theorem 8.8. Okay, now you can prove it. So this is our proof for the second statement. Okay, so initially we have proved the first statement that this quadrilateral is a parallelogram. Now we have proved this quadrilateral is a parallelogram. Okay, this is done. So in the next phase we will solve or we will prove the third statement, that is PSQR. This one is a parallelogram. Okay, so let's have another page. So we have proved the first statement, APCQ is a parallelogram. The second statement, DPBQ is a parallelogram. Now it's turns for proving the third statement, that is PSQR. This one, PSQR quadrilateral is also a parallelogram. Okay, so let us prove. So initially from the statement 1, as we proved what? That APCQ is a parallelogram. So write it down first. As APCQ is a parallelogram. Okay, done. So APCQ, okay, CQ, this one, this quadrilateral, this is a parallelogram. Okay, if it is a parallelogram, then we know in a parallelogram the opposite pair of sides are what? Parallel. Okay, so for the parallelogram APCQ, can we write AQ is parallel to PC? Yes, because they are pair of opposite sides. We can write AQ is parallel to PC. Okay, we can write AQ is parallel to PC. We know that in a parallelogram the pair of opposite sides are parallel. Now we have written AQ is parallel to PC. Now see here, SQ is a part of AQ. Yes or no? Yes. SQ is a part of AQ. Similarly, PR is a part of PC. If this is AQ and this is our PC, okay, then I have told you that SQ is a part of AQ, correct? This is R. PR is also a part of PC. Since it is given AQ is parallel to PC, then can we write this part is also parallel to this part, because they are also the part of those two parallel lines. So we can write that SQ is parallel to what? PR. SQ, this one, AQ is parallel to PC. So SQ is a part of AQ. So SQ is parallel to PR, because both SQ and PR are the parts of AQ and PC respectively. Okay, this is clear. Let's say this is our question number 1. Is it clear completely? Okay, next. From the second statement, what we have proved? We have proved that DPBQ is a parallelogram. DPBQ, DPBQ, DPBQ. This quadrilateral, okay? This quadrilateral, this quadrilateral. So you can write as DPBQ is also a parallelogram. Parallelogram. So here also you can write their pair of opposite sides are parallel. Okay. For the quadrilateral or for the parallelogram DPBQ, this one. See this one. So can we write this side is parallel to this side? Yes, we can write, because we are considering which quadrilateral? This one. DPBQ. So we can write that DP, that means this side is parallel to this side BQ. Okay, we can write they are parallel. So let us write them. So we can write that DP is parallel to BQ. Now look at this figure. If we consider DP as a side, right, then PS is a part of this DP or not? Yes. P, suppose this is S. So PS is a part of DP. Clear? Similarly, if we consider BQ as a side, as a line, then this RQ is a part of this BQ or not? Yes. Let's say this is R. So this RQ is a part of BQ. Yes. Since already we know that this line is parallel to this line, that means this part is also parallel to this. So we can write that PS, this one, PS is parallel to Q1. Okay. So PS is parallel to Q1 or RQ, whatever you can write, no problem at all. PS is parallel to Q1. Okay. So this is the second number equation, equation 2. Equation 2. So from the equation on what we have got? We have got SQ is parallel to PR. SQ. This is SQ. SQ is parallel to PR. Okay. I have marked it. Symbolically I have marked it. And in the equation 2 we have found PS. PS is parallel to QR. PS is parallel to QR. Now you can see this. Carefully look at this. If we consider PS QR as a quadrilateral, then in this quadrilateral, this side is parallel to this side and this side is parallel to this side. Then what it will be? It will definitely be a parallelogram, because in a parallelogram the pair of opposite sides are parallel, we know. And here in this figure, in this quadrilateral, we found that their pair of opposite sides are parallel. We found it. So we can write for quadrilateral PSQR. Okay, what we have found? We have found PS parallel to QR and this SQ is parallel to PR. Okay, so the pair of opposite sides are parallel. That means this quadrilateral is nothing but a parallelogram. Hence, PSQR is a parallelogram. Okay, now it is proved. So in order to prove the third statement, we use we take the help of the first two statement. Okay, so now we have proved the complete question, and PSQR is a parallelogram. Now it has been proved.